welcome back to Beta YouTube channel after a very long time. Today we are going to start off with binomial theorem. So a very important topic but an easy one. So binomial theorem is basically the studies of expansions of expressions like x plus y whole to the power m. So we know from our childhood that a plus b whole square is equal to a squared plus 2ab plus b squared. Now this can be derived using a binomial theorem. Now a plus b whole square is a particularly simple case. You can derive it by using basic algebra, geometry and so on. But what about a plus b whole to the power 50? What if I ask you what is 3x plus 2y whole to the power 3? Basically you are going to use the cube formula. You are going to say it is 3x cubed plus 2y cubed plus 3 into 3x into 2y into 3x plus 2y. Okay, but what about 3x plus 2y whole to the power 70, right? You cannot compute it like that so easily. Therefore, in order to answer these questions, we have binomial theorem. So this theorem was invented by the famous mathematician Newton. So in order to study this theorem, first of all we need to understand the language of factorial or the symbol of factorial. Now r factorial, or it is sometimes written as r factorial, is the product of r consecutive natural numbers. It is r times r minus 1 minus times r minus 2 times r minus 3 all the way up to 3 into 2 into 1. So 5 factorial is basically 5 into 4 into 3 into 2 into 1. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, and 120 times 1 is 120. So 6 factorial is basically 6 into 5 into 4 into 3 into 2 into 1. So it is basically 6 into 5 into 4 into 3 into 2 into 1 is exactly what we have calculated over here. So it is 120. So 6 into 120 is 720. So 6 factorial was basically 6 into 5 factorial. So we can write this as a property. N factorial is n times n minus 1 factorial. So a very simple property and an obvious one, but this will help us in future to solve certain questions and to minimize our calculations. Now it would be advised to memorize the values of first 6 factorials. So one factorial is 1, 2 factorial is 2 into 1 which is 2, 3 factorial is 3 into 2 into 1 which is 6, 4 factorial is 4 into 3 factorial by using this property. So 4 into 3 factorial is 6, which is 24. 5 factorial is 5 into 4 factorial, or we have already calculated it over here, which is 120. 6 factorial is 720. Now remembering these 6 will do. In addition to these 6, you have to remember one more thing, which is 0 factorial. 0 factorial has been defined to be 1. Now there is a very good analogy or an explanation to this. So following this theorem, whenever you go back 1 factorial, that is whenever you go from 6 factorial to 5 factorial, you divide by 5. So divide by 6, dividing 720 by 6, you get 120. Dividing 120 by 5, you get 4 factorial. So dividing 24 by 6, dividing 24 by 4, you are going to get 3 factorial. Dividing 6 by 3, you are going to get 2 factorial. Dividing 2 by 1, dividing 2 by 2, you are going to get 1 factorial, and dividing 1 by 1, you are going to get 1 again. So from here you can say that 0 factorial is 1. Now you might say that why cannot we proceed like this further to define minus 1 factorial. Now minus 1 factorial is a little tricky, because after getting 1 factorial twice, after getting 0 factorial, you cannot divide by 0. You have to divide 1 by 0. According to the process that we have followed, when we were going back each factorial, we were dividing by that number, right? So here you have to divide by 0, which is undefined. So negative 1 factorial cannot be defined by this process of multiplication. Of course, negative factorial of negative numbers and fractions have been defined, but they are far beyond the scope of our syllabus. Okay, so this was one thing which I needed to tell you.